So we now have Professor Yogendra Simha to talk to us. This was the title. Well, I don't know what specifically looking back,
Can you hear
sounds like. But let me just very
Can you hear
briefly.
me now?
Yes, Professor Simha, we can hear you. Just give me one moment so that I can introduce you to the audience. Professor Simha, many years ago, did his bachelor's from Bangalore University. He was a master's graduate from ISC, from the Mechanical Engineering Department. He then went on to do his PhD at the University of Maryland. Professor Simha, has been mentioned, has been, I would say, a leader in leading our tradition on experimental solid mechanics at the Institute. He has influenced generations of engineers in India, not only through his research, but also through his mentorship. He has been a fatherly figure to research students and to young faculty members, including myself. As his office neighbor on the third floor, I have very fond memories of interactions with him. Beyond everything else, Professor Simha brings people together. So it is only fitting that on the occasion of his retirement, he brings us together through this symposium. It's a pleasure for me to request Professor Simha to talk to us. Professor Simha, the mic is yours.
Thank you very much, Dr. Ramcharan. Could you hear me now?
Yes.
About all the people in the audience, are you sure they are able to hear me out?
Yes, Professor Simha, please.
Yes.
Thank you very much. That makes me more confident to say a few words at this point, for this very interesting event that you guys have planned for me. It's not easy to get so many speakers, in a situation like this, but I congratulate you and all the people who have organized this virtual meet, to make sure that, all the youngsters around the world get together and share their ideas, both in terms of what they're looking forward to and where they're headed. But as far as I'm concerned, as the title of my lecture says, I'm supposed to also look back also while looking forward to whatever comes up. Once again, I thank the Department of Mechanical Engineering for organizing this event and all of you to get together like this, bringing in more than about 2 dozen. I think there are more than 23 speakers, including me, that will be 24, and then you also have a panel discussion this evening. So I thank you all for this wonderful, memory that I will cherish forever. There's not much to talk about in terms of what is it that I did. But whenever you look back, you always look back to your teacher and their teachers and so on. It is something like looking back as you're climbing down a hill or a mountain, and the only thing you see is the peak from where you are getting down. And when you see that, you see that there are peaks further higher than your own achievement. And these are your teachers, and then their teachers. So this tradition which of looking back and remembering our teachers makes us feel young, as if we are in a classroom. So I'm very happy that I'm able to share with you some of these memories that has kept me going so many years. And I'm sure you guys will be doing the same thing 20, 30 years from now, and find out, what type of peaks you climbed and how high you could go in your field. I must say in this context that whatever little that I have achieved in my professional life is all due to some great teaching that I cherish even today, and some of the best teachers that I had right from a very early age all the way up to my PhD kept me going in this field. And I feel that these teachers, who were so many and spread all over the world, would, each of one of them, I can talk about them for hours, but given the constraint of time and so on, I again give a big salute to all those big guys, great guys, who actually shaped my professional career. And therefore I was able to take up guiding those students who came along to work with me here at the Indian Institute of Science, Bangalore. So I think it would be very important for me to also, before I get going with my story, to thank profusely all my students at all levels of PhD, Master, MTech, and students from not only our department but also other departments and even other universities all over the world who have shared their excitement of doing the research with me, and also welcome my suggestions and carried on their own to conduct their research and get their respective degrees and move on. And some of them, I'm sure, are doing very well, both academically and professionally, and some of them have become entrepreneurs, some of them have their own business, some of them, of course, have made so much money they have retired as well and enjoying life. I feel happy that all this effort that I was able to contribute to, some knowledge and some welfare of our students, and I was able to learn a great deal from them, as I did from my teachers. So once again, as I was telling you, looking back is like looking back top of a hill and find out how high you could do it. Whatever you see, above the surface is just like a tip of the iceberg. The iceberg, you see only 10% sticking out of the water surface. So also, if you look at the amount of land mass, even though the land mass or the area is about 30%, the oceans are deeper. In fact, the average depth of the ocean is like 4 times the average height of the land on which we live. Therefore, whatever we have learned or whatever knowledge that I have acquired is, probably like the tip of the iceberg. There's a lot more that I had to learn, or we all have to learn, and for that we have to go deeper into the ocean of mysterious and secrets that continue to come up on the surprise us with so much knowledge out there, which we have to somehow get deeper and bring it out. So in this context, I must say the phenomena with which I was working on right from my college days, continue to haunt me, and I have not been able to find all the answers that I was looking for during my college days, to my master's and my PhD, and even after I became a faculty member here, and even today, I am not sure whether I have even gone even 100 meters deep into this ocean of uncertainty and knowledge, which is still out there for you guys to go and get it out. One particular area which I'm sure all of you would agree with me is the area which first talk by Dr. Sundar started out, how fatigue crack can keep going out of so many other supplementary phenomena like diffusion, creep, high temperature, and so on. So there is no end to this fracture process. It happens at the very smallest atomic level, or it can be as big as a cataclysmic fracture event, as you might see in an earthquake, running along for thousands of kilometers and generating all kinds of damage. Like if you remember, I don't know how many of you are, in school or even in college, we had a huge tsunami in our country, and I'm sure many it affected almost the entire half of the world, where the waves which are unleashed by that earthquake, so powerful that even today people are trying to analyze what happened. On the other hand, we also have small, phenomena, the crack tip, which was so interesting that if you have the right experimental tools to capture all the events that occur at the crack tip, you will be surprised that when a crack propagates at high speed, you can pick up out of the crack tip electrons and even light, this kind of radiative processes which accompany fracture. I'm sure are still out there for you guys to go and explore. So what I'm trying to say is that I look back, I only look at the bigger peaks behind me that continue to guide the thinking process. And in this respect, I think if you go right back to the top of the highest peak, you will see the great masters who started the field going, kept the field going right from the days of, when, maybe thousands of years ago. But then if you come down the peak, you get into the Newtonian mechanics and so on. And then as you climb down, you will get into the modern era, which is full of all kinds of strange matter, all kinds of devices, quantum effects, and all that. So I think today the real challenge for youngsters like you is to understand new materials. So when I say new materials, what I mean materials on the very, very smallest scale. As you find in earlier, the feature was in MEMS. Now we are going down a few orders of magnitude further down to the level of nanometers. So in order to figure out what is happening at these small length scales, it is important that we have a good grip of the physics and chemistry at these length scales. So I think this challenge is now slowly becoming important in the area of fracture as well, where we have to look at situations where individual molecules or atoms are split apart to allow the crack to go through. So I think these are the challenges which
Is anyone else having trouble hearing him? I think he has dropped out.
Yeah, even I can't hear him anymore.
sorry, I'm sorry.
No, we lost him for about 10-15 seconds.
Are you able to hear me now?
Yes, this is fine.
I don't know what happened. Sometimes I'm extremely sorry that even while the
No problem. Please continue. Please continue.
sorry that there are some things like this which bothering me. But as I was telling you, you look back at the phenomena of the small length scales, you'll be surprised that modeling these events is not easy. On the other hand, even capturing these events or the phenomena and experiments is even more difficult. So I think future of some of these areas in which people are trying to get the old knowledge and integrate it with the new knowledge of quantum mechanics and quantum chemistry is going to be a really challenging affair for the youngsters who wish to take up some really fundamental, level of exploration into fracture. On the other hand, we should not forget that the future of higher learning depends on how we can utilize our knowledge to improve our health, environment, and of course all the things we consume on a day-to-day basis without making our world too contaminated. In this respect, I must say that a lot of research which can be done today includes such materials which are neither considered crystalline on the one hand or considered fluid-like on the other hand. There's a lot of big group between the two extremes of rigidity and fluidity, and that's where I would like to say that people who are looking at soft matter, like the previous presentation by speaker was very interesting, where she got in the effect of very soft, flagella, which can do wonders for you. If you only know how the mechanics of these materials help in design. So the design, in my opinion, has to always make sense for the manufacturing. So I always think that engineering is trying to make sure that you know your mechanics, you know your materials, and you know your manufacturing. This is the famous 3M triad, which has guided the design process for so many years. So I think many of these things, I feel that today as youngsters, you should not forget that the classical knowledge that you learn at your undergraduate or the master's level, you should go deeper into these classical concepts which have shaped all of us, and I'm sure as you move along, you'll see that the classical concepts continue to give a lot of support as you move along with your simulations or your high-end computing. I think today the situation with computations and simulation is that they're much more interested in success rather than trying to figure out what happened during those failures. So I think one of the things that simulations should also strive to do is to look at those phenomena where the underlying physics or the code gives wrong results, which are not in tallying with experimental observations. I think this is where I think the most challenging type of work can be done in the specific area of soft matter, in which we are talking about Young's moduli on the orders of tens or hundreds or maybe a few kilopascals. So in these materials, I think some of the classical areas of thinking are not likely to give good results. So one has to take a course to some experimental observation. In this context, I'm extremely happy that some work that has been going on in development has given me a lot of inspiration and confidence that there's a lot more to be done in the specific area of fracture and disintegration and degeneration and fatigue of these materials, which are of course the backbone, or should I say the material that make up our bodies, and who knows everything else that is going to be replaced in the future. I think all of this can only come out of a proper understanding of mechanics of very soft materials, for which the ideas of continuum mechanics and other areas, related areas of viscoelasticity, and even I think to some extent two-phase flow and fluid mechanics, and all these areas have been brought in together so that we can go forward into this. I'm telling you, this kind of situation of talking about the future is always fraught with the opportunities one gets. In good old days, we used to go for the real serious unsolved problems, even if it took us a long time or even decades. But today, I think the world is looking at much faster, results, and therefore, choose a problem to work on. I think we have to make sure that the problems are also of interest to the society or the industry that is going to sponsor this type of research. In that respect, I think the industry and the corporate support that the institutes are getting these days is far higher than it used to be about 10 or 15 years ago. I really think today there is golden opportunity for youngsters like you to take up problems pertaining to global R&D problems, pertaining to both healthcare products and industrial R&D products, in which you have to bring in this, the basics of mechanics into the design table, because many of the industries, because they have to deliver fast rate, they sometimes may or may not have the time to get into the fundamentals of mechanics here. I think that's where I think PhD students and faculty, young faculty, should get together and try to put more fundamental mechanics into onto the design table, so that when the products come out, they will not only help the society but also they're sustainable. I'm afraid that many of the products and remedies that we continue to rely on are good in the short term, but sometimes they may or may not give good results in the long term, because the long-term effects of many of the products that we take for granted are not really well known to us, and that's where I think fracture mechanics gives a big hand, because fracture mechanics is all about prediction of residual life, of useful life, which I think can be done very accurately if you are able to understand the mechanisms of fracture in a particular material. So I think kind of subjects I got involved, basically in the areas of fracture, fatigue, and friction, and these areas are basically dissipative processes where the energy is slowly dissipated due to these irreversible mechanisms. I think the rate at which the energy is dissipated is also the spread of dissipation, or the spread of the damage from the crack tip and surrounding area. They're very complicated molecular phenomena. I think some of these things have to be worked out in greater detail in these new materials which I talked about. And that's some way you can push the envelope of this subject. Of course, another interesting area which I'm very fond of is my association with sports for a long time, and that has got to be, of course, impact mechanics. So sports is all about impact. You get hit, you hit the guy, or you get hit, or whatever. I think the impact phenomena which we are trying to study at the institute and also all over the world, require a lot of experimental and computational support. And I'm afraid both are very expensive because experimentally on the field, setting up these experiments are not only hazardous, also very dangerous, and sometimes you need a lot of permissions and regulations and all that. But in this respect, I'm extremely happy that I was able to share some of the most exciting field work during my research career all over the world, and I'm sure that has kept me in good understanding of the subject. But I do feel that the subject of impact mechanics, whether you're talking about a small impact of a small tiny object inside the body or the big objects colliding in outer space, I think it is very important that we understand that a lot more work needs to be done in this connection. I'm sure some of the projects that we are getting from our different agencies, from space and defense and even automobile sectors, is only going to make the situation very promising for youngsters to take up this area. So I think there's so many other areas I can talk about, but I feel that given this opportunity for me to interact with youngsters, I know I would have loved to see all of you in a nice auditorium, and say Jane Tata auditorium, and discuss these things in greater detail, more personally. But I'm very happy that this virtual symposium, YRM, for me is not only a young research meeting, but also I would like to call it as a YRV in mechanics. So the M for mechanics makes a lot of sense. And then this meeting is followed by a two-day event conference on experimental solid mechanics, ESM. So in this connection, I must say that there is a society called the Society for Experimental Mechanics, which is SEM, which is earlier started out as a Society for Experimental Stress Analysis, long time ago, about almost more than 75 years ago, in the year of 1943, I think. So what I'm trying to say is, even though we have completed 75 years, our department has finished 75 years. Our department has finished 75 years, and the societies have finished 75 years. Still, I think these problems which keep coming up are endless and inexorable, and I don't think you'll ever say that the experimental mechanics will ever go out of date. It only means that number of people who are able to generate good results is, I hope, will increase further. But I'm sure with all kinds of sophisticated instruments and computational support that we have today, we can go a long way in this field of experimental mechanics, particularly into phenomena which are very rapidly executed as an impact and fracture, or other phenomena under hostile environment like underwater or high temperature, combustion, blasting, and all these areas. I think experimental mechanics today is all headed in that direction of high strain rate, high velocity, high speeds, and so on. Just as I'm talking to you, there are situations of big flooding which might occur, or a huge amount of rain that is going to fall during the monsoon. Here, I think these are situations which have not been really studied. But I think integrating the natural elements, the fusion of 5 elements, earth, fire, water, and the 5 elements, I think into the research is a way to go. I think I would like to stop here, and maybe if I'm allowed to interact with the youngsters, I'd be happy to take a few questions. But before I did that, I would like to once again thank the organizers, the department, chairman, all my colleagues, so many decades from all over the world who have always been with me. and continue to be with me for the next 2 days. Thank you all, and I look forward to a small tete-a-tete with some of these people who are around. Thank you.
Thank you, Professor Simha. One of the things I learned from Professor Simha is about teaching fracture mechanics. And what I remember is that it's best taught with humor. So I would like, there are a lot of comments coming through the chat window. I have the unenviable job of filtering them. If you would, I am not sure if we have time to hear from everyone. We can certainly hear from a few. Maybe I can request Professor Lakshman Rao to say a few words. He has worked closely with Professor Simha on the Indian Society for Applied Mechanics. Professor Lakshman Rao, you can speak up.
Professor Simha cannot believe that you're retiring, but there's no retirement for a person like you. You continue to inspire most of us, and I am sure you will be much more active through the society that you have to create. So it was a great pleasure working with you all through the few years that I've known you, and I really hope that your spirit will continue to inspire many others who are here in this country. Thank you.
Oh, thank you, Lakshman, for some nice comments. Thank you.
Dr. Rajiv Chaturvedi, who is a student of Professor Simha, you can please, you have been unmuted, you can speak up if you like.
Yeah, good evening, sir. It's actually really pleasure for me to work under your guidance. You really encouraged me to take a complex problem and always encouraged, and with your dedication now I have given an encouragement to work on the complex problem impact mechanics. And with your encouragement, actually, we want to tell that we are going to implement shields in the satellite. So I really want to thank from bottom of my heart for all your support and encouragement during my PhD work.
Thank you, Rajiv. Thank you.
Professor Arun Shukla, who was a classmate of Professor Simha in his graduate student days, is also here. Professor Shukla, you can speak up if you like.
Am I unmuted now? Or?
Yes, we can hear you.
Okay.
I can hear you, Arun. Go ahead.
Simha, great talk, and you raised some really excellent points, And first of all, I just want to say that, you very happy retired life for you. I know it's just retirement on paper. You will always be active and mentor students and help your colleagues there with research and these workshops that you organize so well. You have been a great friend to me. From your talk, Simha, one point I wanted to mention was I hope these youngsters pick up challenges in experimental mechanics and also learn to differentiate between experiments and testing, because nowadays I see a lot of people conduct standard tests and somehow call them experiments. When you and I did the experiments in the lab, the physics of the problem was not known a priori. We didn't know exactly what kind of results we will get, what kind of phenomenon will happen. We always indulged in trying to understand those with long discussions and arguments with our mentors, as to what is right and what is wrong. So I hope the youngsters learn from your talk and contribute to the field of experimental mechanics. Thank you. Thank you very much, Simha.
Thank you, Arun. For those of you who may not know, youngsters around here, Professor Arun Shukla was the past president of the Society for Experimental Mechanics, which started out, as I told you, in the year 1943 at MIT. Bill Murray was the first president. Then we had other presidents all the way were associated with people like George Irving, father of fracture mechanics. Thank you, Arun, for your very nice gesture. Thank you.
We have time to hear from a couple of more people. Tejas or Dr. Ramakrishna and Mr. Yella. One of you can speak up.
Mr. Yella Reddy.
Yes, Dr. Yella, right.
It'd be nice.
If you want to speak up, you have been unmuted.
Oh, Professor Yella Reddy, I hope you can hear.
I'm sorry. Thank you for inviting me. I'm sorry I couldn't see any of the slides of Professor Simha.
Actually, there were none. It was
okay.
audio version.
Well, I wanted to apparently I'm giving more knowledge to my students, but I certainly would like to discuss with you as my teacher, sir.
Well, thank you. Professor Simha was a good student and a good man. All through his career, I have followed him. I have been in Bangalore and elsewhere, but I have followed him. He is a good man. He has helped his students and others also. I wish him well. Thank you very much, Professor Simha. Noranappa.
Thank you very much, sir. Professor Elaradi, I would like to say to the youngsters today, the very great experimentalist, particularly in impact experiments. He was trained at Cambridge, and he heard some of the big shots. You can read in the text like Bill Johnson and all those people were his teachers, and he also was instrumental in contributing the Journal of International Journal of Mechanical Sciences. Thank you very much, Professor Elaradi.
You're welcome.
Thank you.
Yes. Tejas, if you don't mind, we can. We will have a chance to talk to Professor Simha again tomorrow. We are running over time a little bit, so I request the audience members to just hold on to their questions. We will have a chance to interact with Professor Simha again in the following 2 days. I just want to stick to the schedule because people may be tuning in from different time zones, and we don't want to. It will be helpful to stick to the schedule. Let me project my screen back up. Thank you, Professor Simha.
Yeah, thank you very much, John, and I hope I will come back for the backup. Yeah.
Yes, thank you.
Thank you.